we're going to look at building the factor form from quadratic formula. So we'll start with a couple things. We'll start with a question that you did specifically, okay? Where the heck is it? Oh, there it is. Y is equal to 9x squared. Was it plus? No, minus 24x plus 16. So we have our standard form, which is pretty important because if we're going to use quadratic formula, we have to realize that we're in standard form. We actually can't use or plug in an A, B, and C from other forms. So one of the first steps is if we want to use this form, we have to make sure that we recognize it's in standard form, which ours is, which is good. And then you had your quadratic formula, which we were trying to figure out what is it? What is the purpose of it? And we noticed in our notes that they set it equal to 0. And then the quadratic formula stated x is equal to negative b plus or minus b squared minus 4ac all divided by 2a. And it turns out that what we're doing is we're solving for x values when our y value is 0. So you went through this whole process. I'm not going to duplicate that again. And you ended up with this, 4 over 3, okay? Which is unique. We only got one value. So we talked about it a little. So just so you don't forget, when we have one value, we're talking about a unique quadratic. It turns out that, assuming that's the vertex there, the vertex is actually on the x-intercept. That's the only way we can have a single x-intercept, is if the vertex is right there. But we need to build the factored form. Maybe that's what the question's asking us here. We could go through all of our factoring again, but we already did do quadratic formula. So we can actually reverse engineer this. I'm going to write out what the factored form looks like. And we're going to write it like this. A is equal to x minus r and x minus s. Okay, and the r and s are just, they happen to be, we'll say r and s are x-intercepts. Now we only have one. Okay. In other words, our r is equal to our s. They're the exact same value. So we're going to still stay in this form, and we're just going to plug things in. So we found that our r or our s, whatever you want to call it, is equal to 4 over 3. So I'm going to rewrite the same factored form, and I'm just going to plug in values that I know. I don't know what a is, and x is always part of our equation. We're going to subtract 4 over 3. And then in our second bracket, the exact same thing. We have 4 over 3. Okay? Now, I got two brackets that are the same. Is there any way I could simplify this?
Yeah, so x minus 4 over 3 all squared.
Yeah, exactly. I'm going to leave it in factor form just because when I square it, I'm actually going to make a connection to something else here. But here's the trick. A. I actually don't know what A is at the moment. Any ideas what we might be able to do to figure that out? I'm going to give you a hint here.
Look at
Notice that there's an A here in standard form, and there's an A here in factor form.
Okay.
That letter never changed. We had an A, a B, and a C, and then we went to factor, we have an A, an R, and an S.
Right.
This is a way of communicating that, C is not C down here. This is a different letter. That's why we use it. But A, we use the exact same letter for. What that's telling us is this coefficient is actually the same.
Oh, it's still 9.
It's still 9. I don't have to do any other math. I can do other math. I can find a point on the graph and plug it in and then isolate for A. Or I can just look at my original version and go, A is 9. Let's just use what we had. So when we go to build our factor form, y is equal to, we use that same 9. And then we have x minus 4 over 3. X minus 4 over 3. That's it. We have a factored form. So we built that from quadratic. We didn't actually have to go through this factoring piece that we've done before. We can use a quadratic formula. And the reason I want you to notice that we can use quadratic formula is because all of our styles of factoring, they work when we have nice integers, numbers that we can factor. But as soon as we get things that are a little more difficult to work with, like long-running decimals, it's very hard to factor them. Quadratic formula works every single time. So if you're ever given a question where you look at it and you're like, I don't know if I can factor this, your step should be to put it in a quadratic formula. If you get values, then you can reverse engineer the factored form if they need it. Or if they're just looking for x-intercepts, well, that's what you'll have. You'll have your two x-intercepts there. Just to show us one last piece, because I said I was going to, we're going to put those two together so that they look the same. Y is equal to 9x minus 4 over 3 squared. Okay, this looks like the only other major form that we use. And the only other major form that we use is known as the vertex form, x minus h squared plus k. Notice the a value, exact same. All three versions, a is always the same. They've used a different letter here. They use h instead, and it turns out in this unique case, h happened to be the x-intercepts. What about k? What do you think k is in this case?
That's like the y-intercept.
It's the y value of the vertex, absolutely right. But what's our like algebraic value? I don't have a number there. How could I represent it with a number?
Like 0.
0, absolutely. That's exactly what it is. We just don't write 0 in because it doesn't change anything.
Right.
So what we've just done, and this is a unique case, we're able to do it relatively easily because of where the vertex was, but we've moved between all three forms. We had a standard form, we went into quadratic formula to find the factored form, and because these two happen to be the same, we're able to very easily find the vertex form for it. And that's it. Those are all three forms that you would work with in a quadratic, okay?